Good morning, students. Current, electricity, and after that, magnetic effect of current. Now we will see some questions based on magnetic effect of current. Okay, first question. You are given one wire carrying current I1. Here it is square lobe of side A and distance A from this wire, carrying current I2. Okay, your question is, what is force? What is force on loop due to wire? What is force on loop due to wire? So chalo, first of all, as it is square loop, I can assume that this square loop is made up of 4 wires, A, B, C. A, B, B, C, C, D and BA. So we will find forces acting on wire A, B, B, C, C, D and A, B. But what is equation? How to find? See what happens. Due to this wire, magnetic field is produced in this region, and due to magnetic field, force is acting on each and every segment. Simple. What is equation? So see, here it is K, force acting on current carrying conductor, in magnetic field, F is equal to, it is IL cross B, and its magnitude, if I want to write that, F is equal to, it is ILB sin theta, where theta is angle between IL and B. And you know how to find direction of force. It is according to IL cross B. Yes, it is according to IL cross B. Okay, yes, how to find direction? We will see here. But see, as this whole square loop is on right hand side of this wire, first of all, we will find what is direction of magnetic field. What is direction of magnetic field? This side. So as current I1 is flowing in this direction, square loop is in this direction, so force is acting in this direction. I in this direction, rep fingers in this direction, thumb is going inside. So yes, magnetic field due to wire, it is inside. Magnetic field due to wire. Magnetic field due to wire is inside, perpendicular inside. Now, current flowing from each and every wire, we know. So first of all, we will find what is direction of each and every force. To see, first of all, current flowing in this loop of this side AB, it is in this direction. Magnetic field due to wire is inside. Magnetic field due to wire is inside. So current flowing in this wire, it is in this direction. Magnetic field due to this wire is perpendicular inside. Yes or no? Current is direction, magnetic field inside. So thumb is in upward direction. So force acting on this wire AB, it is in this direction, on its center of mass. So yes, it is force F AB. Any doubt? Similarly, force acting on wire BC, current is flowing in this direction, magnetic field is inside. So thumb it is in this direction. So on this wire, force is acting in this direction. That is FBC. Any doubt? Okay. Now, force acting on this wire, see, current is going in this direction. Magnetic field inside. So force is acting in downward direction. Yes. Force is acting in downward direction. So here, force acting on this is in downward direction. That is FC. It is FC. Okay. Now on wire DA, current flowing, it is in downward direction. Magnetic field inside, so it is in this direction. So yes, force acting on this FBA, it is in this direction. So first of all, identify direction of forces. Yes, first of all, identify direction of forces on each and every element of loop. And from this figure, you can easily say, you see here, forces acting on segment AB and CD. They are in opposite direction and of same magnitude. Why same magnitude? Because these two forces are at equal distance from this wire. These 2 points are at equal distance from this wire. So yes, they are of same magnitude and the result will become 0. So here I can say F AB plus F CD is equal to 0. F AB plus F CD is equal to 0. Resultant on this 2 wire segment is 0. Now we have to find what about FBC and FD. The direction is opposite, but their magnitudes are not same, because this wire is a distance A from wire and it is a distance 2A from this wire. So yes, due to changing distance, magnitude of magnetic field changes and force also changes. But for this two, see, distance is same, distance is same. For this two, different distance different. Okay. So now, first of all, I will find what is force acting on wire BC. Before that, I have to find what is magnetic field at this wire BC. Okay, so let magnetic field at part BC due to I1 current in wire. So I will write it as B, magnetic field at point at part BC. Yes, what is equation due to a straight wire, long wire? Its equation is this: mu 0 I upon 2 pi r. Yes, you have to make changes. Mu 0 I1 upon 2 pi r means what is total distance of wire to this BC part? It is 2a. So it is equal to it is mu 0 I1 upon it is 4 pi a. And out. Okay. So therefore, force acting on part BC, okay, that is FBC, is equal to, see in this equation, angle between IL and here, angle between IL and theta, here it is 90, because current is flowing in this direction and magnetic field is inside. So when IL is perpendicular to magnetic field, theta is equal to 90, sin 90 is equal to 1. So F is equal to it is ILP. So chalo, force acting on part BC. What is current flowing in part BC? I2. What is length of part BC? It is A. And what is magnetic field? So this one. It is mu 0 I1 upon 4 pi A. A cut. So I can say it is mu 0 I1 I2 upon 4 pi. Mu 0 I1 I2 upon 4 pi. And now similarly, in the same manner, we can find what is force acting on D. Okay, so first of all, magnetic field at part dA due to I1. So I can write P dA is equal to mu 0 I1 upon 2 pi. What is distance from this to this? It is only A. So yes, here it is only A. Now force acting on part D, force acting on part dA. So what is force acting on part dA? Force acting on part dA, F dA is equal to it is equation again ILP. What is current flowing from part dA? It is I2. Its length is A. And what is magnetic field? It is mu 0 I1 upon here it is 2 pi A. Okay. So yes, again A cut. So FDA is equal to it is mu 0 I1 I2 upon 2 pi. And out. Okay, so FDA is equal to mu 0 I1 I2 upon 2 pi. Now see, from this, which value is more? So obviously FDA is greater than FBC. Okay, so here resultant force here resultant force F is equal to this FDA minus FBC. Why FDA minus FBC? Because FDA is greater than FBC. So is equal to mu 0 I1 I2 upon 2 pi minus here it is mu 0 I1 I2 upon 4 pi mu 0 I1 I2 upon 4 pi. So is equal to mu 0 I1 I2 upon 2 pi 1 minus 1 by 2. Okay, 1 minus 1 by 2 is 1 by 2. So I can say is mu 0 I1 I2 upon 4 pi. And see, resultant force will be acting in which direction? As FDA is greater than FBC, resultant force is acting in this direction F. Means from this wire it is moving away. So I can write it is repulsive. I can write it as repulsive. Clear? See, this question we can solve in short method with the help of that case A. What is force acting between two parallel wires? Yes, we know equation. Okay. If we have two parallel wires carrying current I1 and I2, then force acting per unit length is equal to mu 0 I1 I2 upon 4 pi r. Yes, we have this equation. Yes, we have this equation. Okay, sorry, it is actually 2 pi. Okay, we have this equation. But why we are not using this equation? Because I want to explain these cases. The why forces acting on this two we do not have to consider. Okay, otherwise yes, you can also use this equation. You can also use this equation. Okay, if you write L this side, then F is equal to it is mu 0 I1 I2 L upon 2 pi r. For this wire BC, it is at distance okay 2a, and what is length of this wire? It is a. So here you have to put a, and here you have to put 2a. So basically you will get the same equation. This one, okay. For this wire, you have to put a and a. So here, if you put L is equal to a, L is equal to a, then you will get mu 0 I1 I2 upon 2 pi. Okay, so that is also one method, shortcut. Okay, short method. Okay, but question is why due to this two? Why due to this two? It is 0. That is explanation of that. Clear? Or with the help of this equation, you can find it is easily method. Okay, and now we know that between two wires, when current is flowing in same direction, there is attractive force, and when currents are flowing in opposite direction, there is repulsive force. Force acting on this is more, so it is obviously repulsive force. Yes, it is repulsive force. Clear about this? Okay, so now next question. You are given again one figure, and your question is find magnetic moment of current flowing is I, and you are given this shape. Now, how to find magnetic moment of this? What is the equation of magnetic moment? So, magnetic moment of loop. Its equation is M is equal to NIA. So it is equal to N. Numbers of terms, only one. So one. I, so that is I. But what about A? What is area of this loop? So see, if you see carefully, it is one square. And of side A. So what is area of this square having side A? We know that it is A square. Plus, you are given 1, 2, 3 and 4. 4 semicircle. So what is area of that 4 semicircle? And yes, what is area of circle is pi r square. It is semicircle, means it is pi r square by 2. But 4 are given, so it is 4 into I can write pi r square by 2. And 4 into pi r square by 2. Pi r square by 2 because they are given semicircle. Okay. Or if 1, 2, 3, 4, you can say it is 2 semicircles. So it is 2 into 2. So it is equal to it is I. Here it is A square plus 2 pi. But what about R? What is radius? So see, this size is A. This size is A. So if it is center, this size will be it is A by 2. So radius is nothing but it is A by 2 whole square. It is A by 2 whole square. So is equal to it is I. here we have to write it is a square plus 2 pi, here it is a square by 4. Okay, so it is 2 cut, here it will be 2. If you take common a, then it is I a square common. In bracket it is 1 plus pi by 2. It is 1 plus pi by 2. So yes, it is your answer. What is direction of magnetic dipole moment? If we consider it as vector quantity, then m is equal to it is I a square 1 plus pi by 2, 1 plus pi by 2. In which direction? See, it is x-axis, it is y-axis. Current is going in this direction. Thumb outside means it is inside direction, so it is means it is k. Clear? So yes, this one you have to remember. Okay. What is the equation of magnetic moment? M is equal to it is NIA. M is equal to it is NIA. Okay. So yes, 2 questions. Okay. Now next question. See, you are given 2 wires having infinite length. One wire in horizontal direction, one wire in vertical direction, carrying same current I. At point P, you have to find what is resultant magnetic field. We know that due to long wire magnetic field B is equal to it is mu 0 I upon 2 pi r. Now mu 0 is same for both. Current is also same in both. 2 pi, that is 2 pi, and distance. See, distance from this wire of point P is D. Distance from this wire is also D. So we can say if it is first wire and it is of second wire, then we can say that P1 is equal to P2, means magnitude same. Next, magnitude same. Now what about direction? See, due to first wire, current is going in this direction, point it is in this direction, so thumb inside means B1, it is perpendicular to board inside, perpendicular to page inside. While in case of I, second wire, current in this direction, point it is upward direction, so thumb out. So B2, it is perpendicular to page outside. Perpendicular to page outside. Means this, due to this both wires at point P, magnitudes of magnetic field are of equal magnitude but direction opposite. So yes, resultant magnetic field at point P, resultant magnetic field at point P, resultant magnetic field at point P is 0. Because they both have same magnitude but direction opposite. Simple. Okay. One more question. If you are given one ring like this and current is flowing from it, then what happens with its dimension, means with its radius? Okay, will its radius increase, remains constant, or we can say anything. Okay, so yes, in this case, its radius increases, means it will expand. Why expand? Because if you observe, current is flowing like this. So if I am taking only such element, current is flowing in this direction, its opposite element, current is flowing in this direction, then we know that when there are two parallel wires carrying current in opposite direction, there is repulsive force between them. And if current is flowing in the same direction, there is attractive force between them. Here, between any two part of ring, current is going in opposite direction. So obviously, there is repulsive force between these two components, and due to that, it will expand. Clear? So just remember this equation. Okay.